Hello grade 10s and welcome back to another video on electric circuits. In this video we're going to be looking at a past paper question. This paper is the Department of Basic Education's NSC exam that was written in November 2019. And the question reads, in the circuit diagram below, the resistance of the battery, ammeter and connecting wires are negligible. You can see at the moment the switch is open and that this is not a series nor parallel circuit. Instead, this is called a combined circuit because the 4 ohm resistor is connected in parallel to the 6 ohm resistor, and this entire parallel connection is connected in series to resistor R. Now question 11.1 says, explain the meaning of the following. A current, remember current is given the symbol I, of 5 amperes. Let's start off by remembering how we calculate current. We say current is equal to Q divided by T. It's a measure of charge flowing through a point in the circuit per unit time. Therefore, to answer question 11.1, we can say a charge of 5 coulomb flows past a point in 1 second. So remember, current is charge per second, and that is why we say 5 amperes is 5 coulomb in 1 second. All right, that is going to give you 2 marks for your statement. Let's go on to question 11.2. It says calculate the effective resistance of the parallel resistors. Here they specifically referring to the parallel resistors. So they do not want the resistance of the entire circuit, just part of the circuit, which is nice because that is an easier calculation than if it was the entire circuit. So we're going to say for 11.2 that 1 over Rp, the effective resistance in parallel, is equal to 1 over R1 plus 1 over R2. The resistance of the first resistor is given as 4 ohms, and that of the second resistor is given as 6 ohms. When we place this or these values into our calculator, we obtain a fraction that is given as 5 over 12. And it is very important to remember that that is not the effective resistance. It is still 1 over Rp. So now we find the reciprocal and we say Rp is equal to 12 divided by 5. And when we put this into our calculators and find the answer in decimal form, we obtain a value of 2,4 ohms. For writing down the formula, you'll obtain 1 mark. For substituting, you obtain the next mark. And for the final answer with the correct SI unit, you obtain the last mark. Let's go on to question 11.3. This question says, which one of the voltmeters, V1 or V2, will show a reading, right? So in other words, will not be 0. So V1 is the voltmeter that is connected over here. V2 is connected at this point. Please remember the switch is still going to be the switch is still open at this point. So the question is, which one of these will show a reading? We can clearly see that voltmeter V2 is connected across the positive and negative terminal of the battery. So this connects to the positive side, that connects to the negative side. But if we look at V2 and we draw a line all the way from here there, we hit a block. So here is an open switch. So that is not connected to any part or any terminal of the battery, even though this side is connected across the positive terminal of the battery. We therefore expect that V2 is going to have a reading of 0. The answer to this question is therefore V1, and that is going to get you 1 mark. Now they say the switch S is closed. Right, so we can go up to our circuit and we can close the switch. Every question that follows will now be based off of the fact that the switch is closed. Question 11.4 says, how does the reading on V2 compare to the reading on V1? Is it higher than that of V1, smaller than that of V1, or equal to V1? Now, it's very easy to assume that since this is connected over a parallel connection, it's equal to V1. But this parallel connection is connected in series with this resistor over there. Therefore, the total potential difference is going to be divided. Some of it will go to resistor R and some of it will be delivered to the parallel connection. So since V1 is going to be divided, we expect that V2's reading is going to be smaller than that of V1. For writing down smaller than, you're going to obtain 1 mark. Let's go on to 11.5, which says, calculate the current in the circuit if 0,3 coulomb passes through the ammeter in 2 seconds. Coulomb is charge, given the symbol Q, and 2 seconds is time, given the symbol T. For question 11.5, we would like to calculate current, which is equal to Q divided by time. So we say 0,3 divided by 2. And that gives us an answer of 1, nope, not 1, but 0,15 amperes. For writing down the formula, substituting, and for your final answer in the correct SI unit, you'll obtain 3 marks. Now we go on to the very last question, which says, the potential difference across resistor R is 5 volts when 0,3 coulomb of charge flows through it. Calculate the energy transferred in resistor R. What do we have available? Firstly, we have 5 volts. That is the potential difference. We also have the charge at 0,3 coulomb. And they are looking for energy, which is given the symbol W. So therefore, we can say V is equal to W divided by Q. We have the value of V, it is 5. W, we do not know, we're looking for that. And coulomb, the 0,3 coulombs is the charge. To solve for W, we're going to multiply up by the 0,3. So we get 0,3 times 5 is equal to W. When we place this into our calculators, we find that the final answer is going to be equal to 1,5 joules. So W is equal to 1,5, and remember it is measured in joules. You're going to obtain 1 mark for your formula, 1 mark for substituting, and 1 mark for your final answer with the correct SI unit. This brings us to the end of this video. Thank you very much for joining me, grade 10s.